We often find ourselves gazing upward, lost in the vast expanse of the night sky, consumed by a fundamental question about our origins. We wonder how the universe began. It is a query that has driven science, philosophy, and religion for millennia, pushing humanity to build great observatories and devise grand theories. We seek to understand the singular moment of creation, the Big Bang, that set everything into motion. This quest for our cosmic genesis is a noble and deeply human endeavor, one that connects us to the very fabric of existence and our place within its immense and unfolding story. It is a story of light, energy, and the birth of everything we know and can possibly imagine. However, there is another question, one that is often whispered in the quieter corners of cosmology. It is a darker question, more unsettling yet equally profound. It dares to look not backward to the dawn of time, but forward to its ultimate twilight. How will it all end? This query forces us to confront the mortality of not just ourselves but of everything. The stars that have guided sailors for centuries, the galaxies that spiral in a silent, cosmic dance, and even the relentless march of time itself, all are subject to an eventual, inevitable conclusion. It is a journey into the unknown depths of the far future, a realm of speculation and theoretical physics. Contemplating the end of the universe can feel like standing on the edge of an abyss. The scale is almost impossible for the human mind to fully grasp, stretching across timelines that dwarf our own existence into insignificance. Will the final moments of the cosmos be a spectacle of cosmic fire, a violent collapse of all matter and energy? Or will it be a slow, creeping cold, a gradual descent into an eternal, silent darkness? Perhaps the end will be something far stranger, a scenario born from the bizarre and counterintuitive laws of quantum mechanics, something that defies our current understanding of reality itself. The possibilities are as varied as they are awe-inspiring and terrifying. Today, we embark on a speculative journey to the furthest reaches of time. We will explore the leading scientific theories about the ultimate fate of our universe, venturing beyond the familiar comfort of the present moment. This is not a journey of certainty, but one of exploration, guided by the light of scientific inquiry. We will travel to the far future, a place billions and trillions of years from now, to witness the potential scenarios for the death of the universe. It is a story of cosmic endings, a final chapter written in the language of physics, and it forces us to consider the ultimate legacy of our fleeting existence in a universe destined for an end. To truly comprehend how the universe might die, we must first understand its current state. We need to take stock of what it is made of and how it is changing right now. Looking out into the cosmos, we see a universe in motion. Galaxies are not static points of light but are rushing away from each other at incredible speeds. This is the great cosmic expansion, a legacy of the Big Bang that continues to shape everything's destiny. The space between galaxies is stretching, pulling them further and further apart. This fundamental observation is the starting point for any discussion about the end, as the nature of this expansion holds the key to our cosmic fate. The driving force behind this accelerating expansion is one of the greatest mysteries in all of science. It is a mysterious, invisible energy source that permeates all of space, known as dark energy. Scientists estimate it constitutes nearly 70% of the total energy density of the cosmos, yet we know almost nothing about its fundamental nature. It acts as cosmic anti-gravity, pushing everything apart rather than pulling it together. When we add in dark matter, which provides gravitational scaffolding for galaxies, we find that ordinary matter, the atoms in our bodies, planets and stars, makes up only a tiny fraction of the universe. This strange composition reveals how peculiar our universe truly is. We live in a cosmos dominated by forces and substances we cannot see or directly interact with, their presence inferred only through gravitational and expansionary effects. As the universe continues to stretch under dark energy's relentless influence, something profound is happening. It is growing colder. The energy once concentrated in the Big Bang's hot, dense fireball is now spread increasingly thin across ever-expanding space. The universe is aging, its youthful fire dimming over eons. This expansion and cooling leads to another consequence. The universe is becoming lonelier. As galaxies are pushed further apart by expanding space-time, distances between them will grow unimaginably vast. Future civilizations, if any exist, might look out into a sky that is almost completely empty, the light from other galaxies stretched beyond their ability to see it. The cosmic web connecting galaxy clusters will eventually unravel, leaving isolated island universes adrift in endless dark void. This journey into a colder, older, and lonelier cosmos sets the stage for its potential final act. In the grand cosmic theater, the most widely accepted theory for the universe's final act is a story of quiet, inexorable decline. This scenario, known as the heat death or the Big Freeze, posits that the relentless expansion we observe today will simply continue forever. Fueled by the mysterious push of dark energy, the fabric of space will keep stretching, carrying galaxies further and further away from one another. This is not a sudden cataclysmic event, but a slow unfolding process that will play out over timelines so vast they defy human comprehension. The universe will not end with a bang, but with a gradual fading whisper, becoming an ever larger, emptier, and colder place. Imagine looking up at the night sky billions of years from now. The familiar constellations will have long since dissolved, and the brilliant river of the Milky Way will be a distant memory. The expansion of space will have pushed all other galaxies beyond our cosmic horizon, their light stretched to wavelengths so long they become undetectable. Our own galaxy, the local group, will have merged into one super-galaxy, a solitary island of matter floating in an endless, impenetrable void. The universe will become a place of profound isolation, where each galactic remnant is entirely cut off from all others, unaware that anything else ever existed in the vastness of the cosmos. This perpetual expansion sets the stage for a universe that is fundamentally running down. According to the second law of thermodynamics, entropy, a measure of disorder or randomness, always increases in a closed system. As the universe expands, its energy becomes more and more spread out, more diffuse and disorganized. The temperature of the cosmos, which has been dropping since the Big Bang, will continue its slow descent towards absolute zero, the theoretical point where all atomic motion ceases. This isn't just a cooling of space, it is the slow death of heat itself, as the universe approaches a state of maximum entropy from which no useful work or energy can ever be extracted again. The implications of this eternal expansion and cooling are profound for the very possibility of life and complexity. A universe that is constantly growing colder and more dilute is a universe that is becoming increasingly inhospitable to the structures we know. The energy gradients that power stars, planets, and biological processes will gradually flatten out. The cosmic engine that has driven the formation of structure for billions of years will slowly grind to a halt. The future in this scenario is one of ultimate equilibrium, a state of perfect, uniform, and unchanging stillness. It is a future where the story of the cosmos concludes not with a dramatic climax, but with a final, serene, and eternal silence. The era of starlight, the beautiful and life-giving age we currently inhabit, is but a fleeting moment in the universe's total lifespan. In the scenario of the heat death, the cosmic lights will inevitably begin to go out. The vast clouds of gas and dust that serve as stellar nurseries will eventually be used up. As the universe expands and cools, these nebulae will become too thin and diffuse to collapse under their own gravity to form new stars. The great cycle of stellar birth and death that has illuminated the cosmos for eons will come to an end. The universe will enter a new, darker phase known as the degenerate era, where the only lights left are the fading embers of dying stars. The stars themselves will begin to die out, one by one. Sun-like stars will exhaust their nuclear fuel, swell into red giants, and then collapse into faint, cooling white dwarfs. More massive stars will have already ended their lives in spectacular supernova explosions, leaving behind dense neutron stars or black holes. The longest-lived stars, the small and dim red dwarfs, will continue to shine for trillions of years, far longer than the universe has existed so far. They will be the last beacons of light in an increasingly dark cosmos. But even their time is limited. Eventually they too will exhaust their fuel and fade into darkness, becoming cold, black dwarfs. With the last star extinguished, the universe will be plunged into an almost absolute darkness, punctuated only by the occasional flash of energy from rare particle collisions or decaying matter. Galaxies as we know them will cease to exist. Over unimaginable timescales, gravitational interactions will slowly disrupt their structure. Planets will be flung from their orbits, and the dead stars themselves will be ejected into the lonely intergalactic void, or spiral slowly inward toward the supermassive black hole at the galactic center. The majestic, spiraling cities of stars will dissolve into a scattered, disorganized collection of stellar remnants, drifting aimlessly through the cold and the dark. This future is a stark reminder of the transient nature of all structure. the universe will be populated by a ghostly menagerie of stellar corpses, black dwarfs, neutron stars and planets, all silently orbiting the galactic center or wandering alone in the void. It will be a graveyard of a once vibrant cosmos. The energy of the universe will be locked away in the slow cooling of these degenerate objects, and the faint, almost undetectable cosmic microwave background radiation, which will have stretched to wavelengths longer than the galaxies themselves. The age of light and warmth will be over, giving way to an era of cold, darkness and decay that will last for an almost infinite amount of time. After the last star has died and the galaxies have dissolved, the universe will enter a new epoch, dominated by the most mysterious objects in the cosmos, black holes. For a period of time so long it's honestly difficult to express in words, lasting for googles of years, that's a 1 followed by 100 zeros, these gravitational behemoths will be the only significant structures left. Supermassive black holes will sit at the hearts of what were once galaxies, slowly swallowing any stray matter, planets, or dead stars that wander too close. Smaller stellar mass black holes will just drift silently through the void. In this dark and empty universe, gravity and black holes will be the primary actors on the cosmic stage. However, even black holes are not eternal. As Stephen Hawking famously predicted, they're not entirely black. Due to quantum effects near their event horizons, black holes slowly emit a faint trickle of particles, known as Hawking radiation. This process causes them to lose mass, ever so slowly. For a solar mass black hole, this process is incredibly inefficient, taking around 10 to the 67th power years to complete. For the supermassive black holes at the centers of galaxies, which can be billions of times more massive than our Sun, the evaporation time is astronomically longer, stretching to perhaps 10 to the 100th power years. It's a timescale so vast that if the entire age of our universe were a single second, the lifetime of a black hole would be trillions upon trillions of years. As these final cosmic titans begin their slow process of evaporation, the universe enters its final phase. The black holes will radiate away their mass in a slow, steady stream of photons and other particles, returning their locked-up energy to the cosmos. As they shrink, the process accelerates, culminating in a final, tiny flash of high-energy gamma rays as the last of their mass evaporates completely. One by one, over unimaginable eons, every single black hole in the universe will disappear, leaving nothing behind. This marks the end of the last organized structures of matter. The universe will have finally erased its last vestiges of complexity and history. With the evaporation of the final black hole, the universe will approach its ultimate state of heat death. All that will remain is a cold, ever-expanding soup of fundamental particles, photons, neutrinos, electrons, and positrons, drifting aimlessly through a near-perfect vacuum. There will be no usable energy left. The temperature will be infinitesimally close to absolute zero. Time will lose its meaning, as nothing of consequence will ever happen again. There will be no light, no motion, no life, no thought. Just a thin, featureless void, expanding into an eternity of cold, empty silence. This is the ultimate end, a state of perfect and final equilibrium. The universe's most likely fate is not a dramatic end but a slow, endless fading, heat death or the big freeze. Galaxies will drift apart, their light stretched beyond detection, leaving our merged local group as a lonely island in a vast dark void. Entropy will rise, energy will spread thin, and the cosmos will cool toward absolute zero. Stars, planets, and life will become impossible as energy gradients flatten and the cosmic engine grinds to a halt. The universe will reach a state of perfect stillness. No change, no warmth, just eternal silence. The story of the cosmos ends not with a bang, but with a final, serene whisper. The age of starlight is fleeting. In the heat death scenario, the lights will go out, one by one. Star formation will cease as gas clouds thin, and the last stars, dim, red dwarfs, will eventually fade into cold, black dwarfs. The universe will enter the degenerate era, filled only with stellar remnants, black dwarfs, neutron stars, and black holes. Galaxies will dissolve, planets will be cast adrift, and the cosmos will become a graveyard of dead stars and rogue worlds. Only faint, undetectable radiation will remain as the universe plunges into darkness. The era of light and warmth will end, replaced by an almost infinite age of cold, silent darkness. After the last star dies, black holes will rule the universe for unimaginable eons. Supermassive and stellar black holes will slowly consume stray matter, but even they are not eternal. Through Hawking radiation, black holes will gradually evaporate, vanishing in brilliant flashes over timescales that dwarf all previous cosmic eras. When the last black hole evaporates, all structure and complexity will be erased. The universe will be left as a cold, expanding sea of fundamental particles with no usable energy or motion. Time will lose meaning, nothing will ever happen again, only a thin, featureless void will remain. The Big Freeze isn't the only possible ending. Dark energy could bring a far more violent fate. If dark energy grows stronger over time, it could become phantom energy, accelerating expansion until it tears the universe apart. This scenario, the Big Rip, would shred galaxies, stars, and even atoms as expansion overwhelms all forces. The timeline could be shockingly short, just tens of billions of years. The universe's end would be a cataclysm, not a quiet fade. The mysteries of dark energy may decide whether the cosmos ends in silence or in a final spectacular destruction. In the Big Rip's final moments, destruction becomes personal. Galaxies are torn apart, stars flung into the void, and solar systems dismantled. Planets, including Earth, are ripped from their orbits, then shredded as gravity fails. Even atoms are torn asunder, the very fabric of matter unravels. In the last instance, all structure dissolves into a sea of fundamental particles. The universe ends not in stillness but in a final, violent disintegration. Everything, down to the smallest particle, ripped apart. So, the culmination of the Big Rip is, honestly, the most extreme and absolute end imaginable in physics. In the last fraction of a second, after all matter has been shredded into a chaotic soup of fundamental particles, the expansion rate of the universe would become infinite. This is the moment of the rip itself. It's not just matter and energy being torn apart, but the very fabric of space-time. The universe would essentially tear itself into an infinite number of disconnected pieces. Space and time, the fundamental stage on which the cosmic drama has played out, would themselves cease to exist in any meaningful way. It's a concept that, well, really pushes the limits of our scientific language. Imagine space stretching so violently that the distance between any 2 points becomes infinite, instantaneously. This is the final moment. At this point, the laws of physics as we understand them completely break down. The concepts of distance, time, and causality lose all meaning. It's the ultimate singularity, not a point of infinite density like the Big Bang, but a moment of infinite separation. There would be no after the Big Rip, because time itself would have ended. The story of the cosmos would not just conclude, it would be erased from existence with no possibility of a new beginning or another cycle. This final cosmic tear represents a complete and total annihilation. Unlike the heat death, which leaves behind a cold soup of particles in an eternal expanding void, the Big Rip leaves behind nothing. The universe wouldn't become empty, it would simply cease to be. Every particle, every field, every quantum fluctuation would be separated from every other by an infinite chasm. It's the most definitive end state a cosmological theory can offer. A true return to absolute nothingness. The energy of the phantom field would have done its work, destroying not only its creations but also the very canvas on which they were painted. The Big Rip remains a speculative, though mathematically possible, scenario. Its likelihood depends entirely on the true nature of dark energy, which is still one of the greatest unsolved mysteries in science. If dark energy is indeed a phantom energy that grows over time, then our universe is not destined for a cold, quiet slumber, but for a swift and violent end. It's a starkly different vision of our cosmic destiny, one that replaces the melancholy of an eternal lonely fade with the sheer terror of a universe being ripped to shreds. The end would come not as a whisper but as a final, definitive and all-consuming tear. But perhaps you know the cosmic story does not end in eternal expansion, either through a slow freeze or a violent rip. Maybe the relentless outward push of dark energy will not go on forever. There is another possibility, another potential fate written in the laws of physics. In this scenario, the ultimate winner of the cosmic tug-of-war is not dark energy, but the oldest and most familiar force of all, gravity. This theory, known as the Big Crunch, imagines a future where the universe's expansion eventually halts, reverses, and begins to collapse back in on itself. It's a dramatic and fiery alternative to the cold, empty endings, a universe that comes full circle. For this to happen, the total amount of mass and energy in the universe must be sufficient to overcome the expansion. While current observations suggest dark energy is winning, its true nature remains a profound mystery. If dark energy were to weaken over time, Or if the universe's geometry is closed like the surface of a sphere, gravity could eventually reassert its dominance. The galaxies, which have been rushing away from each other for billions of years, would slow their retreat. They would pause for a moment at the peak of their expansion, hanging in the cosmic balance before the inevitable fall begins. The great cosmic expansion would run out of steam, and a new era would dawn. The beginning of the collapse would be subtle. Distant galaxies would no longer show a red shift in their light, but a blue shift, indicating they are moving toward us instead of away. As billions of years pass, this blue shift would become more and more pronounced. The sky, once growing darker and lonelier, would start to become brighter and more crowded. Galaxies would rush toward each other with ever-increasing speed, their light converging from all directions. The cosmic microwave background radiation, the faint afterglow of the Big Bang, would begin to heat up again, its wavelengths compressed by the shrinking space, slowly turning the darkness back into a warm, then hot, glow. This is a universe where gravity gets its revenge. After eons of being on the losing side of the battle against dark energy, the fundamental force of attraction would finally take control of the cosmos's destiny. The universe would be on a collision course with itself, every particle of matter and every joule of energy destined to meet again in a single infinitesimal point. This is not an end of dissipation and decay, but one of concentration and immense energy. It's a future that mirrors the past, a grand-scale cosmic rewind that promises a conclusion as spectacular and violent as the universe's own birth, returning all of existence to the furnace from which it came. As the Big Crunch accelerates, the universe would become an increasingly hostile and chaotic place. The orderly cosmos we know would be thrown into reverse. Galaxies, once separated by unimaginable distances, would begin to merge and crash into one another. These collisions would trigger furious bursts of star formation, lighting up the contracting universe with the brilliance of countless newborn, massive, blue stars. However, these stars would be incredibly short-lived, quickly exploding as supernova, and leaving behind a cosmos filled with neutron stars and black holes. The sky would be a terrifying spectacle of colliding galaxies and exploding stars. A cosmic demolition derby on an unimaginable scale. The universe would grow hotter and denser with each passing moment. As space itself compresses, the background temperature would rise relentlessly. First, it would become hot enough to cook the surfaces of any remaining planets, boiling away their atmospheres and oceans. Soon after, the stars themselves would be unable to shed their heat into the increasingly hot surrounding space, and would effectively be baked from the outside in. The universe would become a cosmic oven, its temperature soaring past thousands, then millions of degrees. The very atoms that make up matter would be torn apart, as the heat becomes too intense for electrons to remain in orbit around their nuclei. In the final moments of the collapse, the universe would resemble a reversed Big Bang. All matter and energy would be squeezed into a smaller and smaller volume, creating a plasma of fundamental particles. The fundamental forces of nature, electromagnetism, the weak force, and the strong force, would merge back together as the energy levels become unimaginably high. Even the black holes, which had grown by consuming matter during the collapse, would be torn apart and merge into a single, universe-spanning super black hole. Everything that ever was would be crushed together into a single point of infinite density and temperature, a final, all-encompassing singularity. But what happens at this final point? Does everything simply end? Some theories suggest something even more profound. Perhaps this Big Crunch is not an end, but a transition. This fiery point of collapse could be the seed for a new beginning, triggering another Big Bang in a cyclical process known as the Big Bounce. In this tantalizing vision, our universe is just one in an eternal series of universes, each one born from the ashes of the one before. The end, in this case, is not truly an end at all. It's merely the prelude to another cosmic dawn, a cycle of cosmic death and rebirth that could continue for eternity. Beyond the epic battles between gravity and dark energy, there are, well, other, stranger possibilities for the end of the universe. These are ideas that emerge from the bizarre and honestly pretty counterintuitive world of quantum physics. One of the most unsettling of these is a concept known as vacuum decay. This theory suggests that the vacuum of our universe, the empty space between particles, is not truly stable. It might actually be in a false vacuum state, which is a temporary, high-energy condition that only appears stable on the surface. If this is true, then our entire reality exists on a precarious cosmic knife edge, vulnerable to a sudden and catastrophic collapse to a more stable, lower energy state. So imagine a vast frozen lake. The surface seems solid and secure, but somewhere beneath it, a pocket of water remains unfrozen. If the ice cracks at that point, the entire lake could shatter in a chain reaction. This is, in essence, the idea behind vacuum decay. Somewhere, at some random moment in space and time, a quantum fluctuation could create a tiny bubble of the true vacuum. This bubble would be a region of space with different physical laws and a lower energy state. Because it's more stable, it would begin to expand outward in all directions at the speed of light, a sphere of total annihilation, consuming everything in its path. The consequences of this event would be, well, absolute. As the bubble of the true vacuum expands, it would rewrite the laws of physics as it goes. The fundamental forces and particles that make up our reality would be replaced by something entirely different. Atoms could no longer hold together. Stars, planets, and even the fabric of space-time itself would be instantly obliterated and converted into this new form of reality. It's an ending that is both silent and instantaneous. You would not see it coming. There would be no warning. One moment, the universe exists as we know it. The next, it is gone, erased by a ripple of cosmic change. This is not just science fiction, it's actually a possibility grounded in our current understanding of particle physics and the Higgs field, which gives mass to particles. While physicists believe our vacuum is likely stable, they can't be totally certain. We could be living in a metastable state, a cosmic house of cards that has stood for 13.8 billion years, but could collapse at any moment. So the end of the universe might not be a distant, slow process playing out over trillions of years. It could be a sudden random event that happens tomorrow, or in a billion years, or perhaps it will never happen at all. It is, in a way, a cosmic lottery we are all playing, whether we know it or not. The Big Crunch offers a vision of the universe collapsing into a single point, but what if that point of infinite density is not the end of the story? What if it is a gateway to a new beginning? This is the core idea behind a theory known as the Big Bounce. In this scenario, the universe is part of an eternal cycle of birth, death, and rebirth. The end of one universe is simply the trigger for the creation of the next. Our Big Bang was not the absolute beginning of everything, but rather the bounce that followed the collapse of a previous predecessor universe. It's a cosmic story without a true beginning or a final end. This cyclical model elegantly resolves some of the puzzles posed by the standard Big Bang theory, such as what came before it. In the Big Bounce model, the question becomes meaningless, as time is part of an infinite loop. As our universe collapses in a big crunch, the incredible density and pressure would not lead to an infinitely small point of singularity. Instead, quantum gravity effects would intervene. These new forces would halt the collapse and reverse it, causing all the matter and energy to bounce back outward, triggering a new Big Bang and creating a fresh universe with its own life ahead of it. Each cycle could be different. Some versions of the theory suggest that the fundamental constants of nature could be reset or altered with each bounce. The universe that came before ours might have had different laws of physics, making it completely alien to our own. The universe that follows ours could be different still. We are just one chapter in an endless cosmic book, one link in an infinite chain of creation and destruction. The universe itself becomes a kind of cosmic phoenix, perpetually dying in a fiery collapse only to be reborn from its own ashes, again and again for all of eternity. This idea transforms our perception of cosmic destiny. It replaces the finality of heat death or a big rip with a sense of eternal renewal. While our own universe would still face an end, it would not be the ultimate end of existence itself. The total story of the cosmos would be one of endless cycles, a grand repeating symphony of expansion and contraction. It suggests a universe that is fundamentally resilient and regenerative. The end might not be a true conclusion, but merely the turning of a page, a quiet moment of transition before the next great cosmic story begins to unfold from the remnants of our own. All these theories, heat death, big rip, big crunch, vacuum decay, big bounce, operate on the assumption that the universe we observe is the fundamental reality. But what if it is not? What if we are living inside an incredibly advanced and complex computer simulation? This idea, known as the simulation hypothesis, is another strange but logically coherent possibility for the universe's ultimate fate. If our reality is a program running on some vast, unknowable cosmic computer, then the end might not be governed by the laws of physics as we know them. The end could simply be the moment the simulation is shut down. In this scenario, the universe would end not because of entropy or dark energy, but because of a decision made by our creators or simulators. Perhaps the simulation has run its course and the experiment is over. The end could come as a simple command: shutdown. The entire universe, every star, every galaxy, every particle, every thought, could simply cease to exist in an instant, like a character in a video game when the console is turned off. There would be no physical process, no bang, no rip, no freeze. Just a sudden, clean, and complete termination of the program we call reality. It would be the ultimate game over. Alternatively, the end might not be a shutdown but a system crash. Like any complex piece of software, our simulated reality might have bugs or limitations. The simulation could run out of processing power or memory as the universe becomes too complex or expands too far. This could manifest as glitches in the laws of physics, strange anomalies that scientists would struggle to explain. The end could be a catastrophic system failure, a cosmic blue screen of death where reality itself freezes and corrupts. Our universe would simply stop working, its program halted by an unresolvable error in its own code. This hypothesis pushes the question of our ultimate fate into the realm of metaphysics. It suggests that the true laws governing our existence might not be discoverable from within the simulation. We are like characters in a story, unaware of the author who might decide to end our tale at any moment, on any whim. While it is a purely speculative idea, it is one that some physicists and philosophers take seriously. It reminds us that our understanding of reality is limited by our own perception. The true nature of the universe, and therefore its ultimate end, could be something far stranger and more artificial than we could ever imagine from our limited vantage point. No matter which of these cosmic endings turns out to be true, one thing remains certain. For us, time is relentlessly running forward. Whether our universe is destined for a cold, quiet fade into darkness, a violent and sudden rip, or a fiery collapse into a new beginning, our own time is finite. We're living in a very special, fleeting moment in the grand cosmic timeline. It is the era of starlight, an age where the universe is vibrant and filled with the light of suns, the dance of galaxies, and the potential for life and complexity. This awareness of an ultimate end does not have to be a source of despair. It can be a powerful call to appreciate the present. The knowledge that everything will eventually cease to exist can feel overwhelming, threatening to render our actions meaningless. If the cosmos itself is mortal, what is the point of anything we do? But perhaps the opposite is true. Perhaps meaning is not found in permanence but in the precious, temporary nature of existence. We are here now. We are conscious. We are a part of a universe that is, for this brief cosmic second, capable of producing beings who can look up at the sky and wonder about it all. The fact that this state is not eternal makes it all the more remarkable and valuable. Our quest for knowledge, our drive to understand these grand cosmic questions, is a testament to this value. Even in a universe that is ultimately doomed to end, the act of asking questions, of learning and of wondering has its own profound worth. It is a rebellion against the eventual silence. We build telescopes to see further, we devise theories to understand deeper, and we tell stories to share our place in the cosmos. This shared journey of discovery connects us to each other and to the universe itself, creating a tapestry of meaning woven from threads of curiosity and awe, even if the tapestry itself will one day unravel. This perspective shifts our focus from the unknowable, distant future to the immediate, tangible present. The ultimate fate of the universe is a fascinating puzzle, a grand story written in the language of physics. But the meaning of our lives is not written in the final chapter, trillions of years from now. It is written here and now, in our actions, our relationships, our creativity, and our capacity for wonder. The end of the universe is a story about physics, but our existence within it is a story about us. And that story is happening right now, in this beautiful, temporary, and extraordinary moment. So we stand here on this small blue planet, armed with our theories and our questions. We look out into the vast, silent darkness and ponder its ultimate fate. The big freeze, the big rip, the big crunch. These are not just scientific concepts. They are cosmic mementos mori, reminders that nothing lasts forever. They teach us a lesson about the preciousness of time. The universe has gifted us this brief, shining moment of warmth and light between two eternities of cold and darkness. It is an invitation to consider what we do with the time we are given, both as individuals and as a species. The future of the cosmos is beyond our control, a grand drama playing out on a stage far larger than we can ever hope to influence. But the future of our own small world, and the meaning we create within it, is not. The awareness of a final cosmic curtain call encourages us to focus on what truly matters. It inspires us to be a little kinder, to learn a little more, to explore a little further. It pushes us to build, to create, and to connect, not because these things will last forever, but precisely because they will not. Their transient nature is what makes them so incredibly precious. Perhaps the greatest legacy we can leave is not one of material permanence, but one of curiosity and understanding passed down through generations. The fact that we can even contemplate the end of the universe is a miracle of consciousness. We are the universe's way of knowing itself, if only for a short while, and in that act of knowing, of questioning and exploring, we find a purpose that transcends the inevitable decay of matter and energy. We find meaning in the search for meaning itself, a light we can hold against the encroaching darkness of the far future, and maybe in the end, that is what matters most, not which theory is correct, or how many trillions of years we have left. What matters is that we were here. We lived. We loved. We looked up at the stars, and we dared to ask the big questions. We saw the beauty of the cosmos. We felt the weight of its mysteries. And we spent our fleeting moment in the sun reaching for a deeper understanding of it all. The universe will end. That much is almost certain. But the wonder we feel in this moment, right now, is real, and it is ours.